Imagine steering a canal boat toward a wide river. The current below is fast and dangerous. The water is deep. One mistake could sink your cargo and destroy months of work. But instead of descending into the river, your boat keeps moving forward. Suddenly, you are sailing across a bridge filled with water, suspended high above the river below. It sounds impossible. Yet throughout the 1800s, American engineers built incredible aqueducts that carried entire canals over rivers, streams, and valleys. These structures allowed boats loaded with coal, lumber, iron, and agricultural products to travel hundreds of miles without interruption. Built decades before bulldozers, excavators, and modern cranes, canal aqueducts were among the greatest engineering achievements of their time. This is the story of how America built aqueducts that carried canals over rivers.
To understand why aqueducts were needed, we first need to understand the importance of canals. In the early 1800s, America was growing rapidly. Cities were expanding, factories were opening, farms were producing more food than ever before. But transportation remained a major problem. Roads were rough and often impassable. Moving a single ton of cargo by wagon could cost a fortune. Then came the Canal Revolution. Artificial waterways connected towns, rivers, and major markets. Suddenly, one horse could pull a canal boat carrying dozens of tons of cargo. Transportation costs dropped dramatically. The success of New York's Erie Canal inspired a nationwide canal building boom. Thousands of miles of canals spread across the country. But engineers quickly encountered a serious obstacle: nature itself. Rivers crossed the paths of many canals, and every crossing created a dangerous challenge. At first, engineers tried simple solutions. Some boats entered rivers directly and crossed to the other side. Others relied on temporary crossings and ferries, but these methods created constant delays. River currents could push boats off course. Floods regularly damaged crossings. During storms, travel often became impossible. For canal operators, every delay meant lost money. A better solution was needed. Engineers began asking a revolutionary question: what if the canal didn't go into the river at all? What if the canal simply crossed over it? The idea seemed almost unbelievable. A bridge carrying water, a bridge carrying boats, a floating highway suspended above a river. That idea became the canal aqueduct. Building a canal aqueduct was far more difficult than building an ordinary bridge. A normal bridge only supports its own weight and the traffic passing over it. An aqueduct had to support something much heavier: water. A single gallon of water weighs over 8 pounds. Millions of gallons would be flowing through these structures every day. Engineers had to calculate enormous loads. Stone arches had to be strong enough to carry not only the canal itself, but also fully loaded boats. At the same time, the structure needed to remain watertight. Even a small leak could weaken the entire system. Many people doubted such structures could survive. But America's engineers were determined to prove them wrong. Construction began long before the first stone was laid. Workers searched nearby hills for suitable stone. Massive quarries were opened. Using hand drills, hammers, chisels, and black powder explosives, laborers cut huge blocks from solid rock. The work was exhausting and dangerous. Dust filled the air. Explosions echoed across the landscape. Accidents were common. Once the stone was cut, it had to be transported to construction sites. Teams of horses pulled heavy wagons loaded with materials. Some projects even built temporary tracks to move stone more efficiently. Thousands of tons of material were required for a single aqueduct. Everything had to be moved without modern machinery. Every block represented hours of labor. Before arches could rise into the sky, workers needed a solid foundation. Engineers carefully studied riverbanks. They searched for stable ground capable of supporting immense weight. Excavation crews dug deep into the earth. Large stones were placed layer by layer. The goal was simple: create a foundation strong enough to last for generations. In many cases, construction crews worked directly beside flowing rivers. Floods constantly threatened progress. Heavy rains could destroy weeks of work overnight, yet workers continued, stone by stone, day after day. Slowly, the foundations began to take shape. The most impressive phase was building the arches. These arches would eventually support the entire aqueduct. First, carpenters constructed huge wooden frameworks called centering. These temporary structures acted like molds. Stone masons then placed carefully shaped stones onto the wooden frames. Each block had to fit perfectly. A single mistake could weaken the entire arch. The final piece was the keystone. Positioned at the very top of the arch, it locked all the other stones into place. When the keystone was installed, something remarkable happened. The arch became self-supporting. Workers could remove the wooden framework. The stone arch would stand entirely on its own. Many aqueducts contained multiple arches stretching across rivers for hundreds of feet. To people living in the 1800s, these structures seemed almost magical. Completing the arches was only half the job. The bridge still needed to hold water. Engineers constructed a channel along the top of the aqueduct. This channel became the new section of canal. Special waterproof materials were used to prevent leaks. Clay, stone linings, and iron troughs helped keep water contained. Workers tested every section carefully. Even a tiny crack could allow thousands of gallons of water to escape. Maintenance crews constantly inspected the structures. Leaks were repaired immediately. Without proper maintenance, an aqueduct could fail. The success of the entire canal depended on keeping water where it belonged. When construction was complete, the results amazed everyone. Canal boats floated smoothly across rivers without ever touching the water below. Passengers could look over the side and see the river far beneath them. For many Americans, it was their first glimpse of large-scale engineering. One of the most famous examples was the Delaware Aqueduct, completed in 1848. Designed by engineer John A. Roebling, it carried canal traffic across the Delaware River. Roebling would later become famous for designing the Brooklyn Bridge. Aqueducts like these helped connect industries across the nation. Coal from mines, timber from forests, products from factories, all moved efficiently through America's growing canal network. Despite their success, canal aqueducts faced a powerful competitor: the railroad. Trains were faster. They operated year-round. They weren't limited by frozen canals or seasonal water levels. As railroads expanded across the country, canal traffic declined. Many aqueducts were abandoned. Some collapsed after years without maintenance. Others were dismantled for materials. The Great Canal era slowly came to an end. Yet many aqueducts survived long enough to remind future generations of what had once been possible. Long before modern construction equipment, America's builders achieved something extraordinary. They created bridges that carried entire waterways through the air. Using little more than stone, timber, iron, horses, and human determination, they solved one of the greatest transportation challenges of their age. These aqueducts weren't just bridges, they were symbols of innovation, proof that with enough ingenuity, even a river could become nothing more than another obstacle to cross. And for thousands of canal boats traveling across America, these remarkable structures truly made it possible to sail across the sky.